Hello, I'm Victoria. Today I will explain the second part of network fundamentals. In this video, you will learn how communication over networks is broken down into different layers, the technologies required to provide a VPN, and finally, the use of a VPN. Let us first start with section 3.1.3, or how communication over networks is broken down into different layers. Communication is the transfer of data from one device to another in a network. This data must undergo 7 checkpoints to reach its destination or the end user. Think of it as an assembly line. At each layer, certain things happen to the data to prepare it for the next layer. These stages are known as the 7 layers of the OSI model, or the Open System Interconnection model. The 7 layers include the application layer, the representation layer, the session layer, the transport layer, the network layer, the data link layer, and lastly, the physical layer. Each layer performs certain protocols to allow the transfer of data. The application layer is the topmost layer of the OSI model, and it is the interface for endpoint service. This layer interacts with the operating system or network applications whenever the user uses network services. These services include data transfer, web surfing, email, virtual terminals, and much more. Protocols of the application layer include all the higher level protocols, such as FTP, HTTP and HTTPS, SMTP, and Telnet. All application layer protocols include DNS, Domain Naming System, HTTP, Hypertext Transfer Protocol, Telnet, SSH, FTP File Transfer Protocol, TFTP Tribal File Transfer Protocol, SNMP Simple Network Managing Protocol, SMTP Simple Mail Transfer Protocol, DHCP Dynamic Host Configuration Protocol, X-Windows, RDP Remote Desktop Protocol, and more. Domain Naming System is a protocol within the set of standards for how computers exchange data on the internet and many private networks. It helps convert easy-to-understand domain names into an IP address. Hypertext Transfer Protocol is a protocol that is used within websites to send and receive data from a server. For example, when you complete a form on a web page and it sends an order to one of the servers after you click Buy Now. Telnet is a client-server protocol that provides the user with a terminal session to the remote host from the Telnet client application. It is used on the internet or the local area network to provide interactive text-oriented communications. Secure Shell is a cryptographic network protocol for operating network services securely over an unsecured network. File Transfer Protocol is a standard for the exchange of programs and data files over a network. Trivial File Transfer Protocol is a FTP which allows a client to get a file from or put a file into a remote host. Simple Network Management Protocol is an internet standard protocol for collecting and organizing information about managed devices on IP networks, and for modifying that information to change device behavior. Simple Mail Transfer Protocol is a communication protocol for electronic mail transmission. Dynamic Host Configuration Protocol is a network management protocol. It dynamically assigns an IP address and other network configuration parameters to each device on a network so that they can communicate with other IP networks. X-Windows is a windowing system for bitmap displays, common on Unix-like operating system. Finally, Remote Desktop Protocol is a proprietary protocol developed by Microsoft, which provides a user with a graphical interface to connect to another computer over a network connection. To conclude, the application layer provides services for network applications with the help of protocols to perform user network services. In short terms, this layer is the program that sends out the data during communication. Next is the presentation layer. This layer receives data from the application layer. It translates, then divides the data into data packets so it can be transported around easier. The presentation layer performs 3 stages to the data. 1. Translation. translating the data from characters and numbers to a standard format using ASCII, binary, or EBCDIC code. This step is crucial since it allows data to be comprehensible by the next layers. The second stage is data compression. The compressed data reduces the amount of space used to store the original file and can be transferred faster to its desired destination. The data can be compressed as lossy, such as JPEGs, or lossless, like zip files. The third and final stage is encryption when sending, or decryption when receiving. This stage maintains the integrity of data before transmission. Data is encrypted to enhance the security of sensitive data. The presentation layer uses SSL, or Secure Sockets Layer Protocol, for encryption and decryption. After the data has been achieved and converted into a transportation format, the next step in the assembly line for the data is in the session layer. This layer helps with setting up and managing connections, enabling the sending and receiving of data, followed by termination of connections or sessions. The session layer has its helpers called APIs, or Application Programming Interfaces. NetBIOS, Network Basic Input and Output System, is an example of an API that allows applications on different computers to communicate with each other. Just before a session is established with the server performs a function called authentication. Authentication is a process of verifying who the user is. This is done by matching passwords and usernames. After authentication, authorization is checked to decide if the user has permission to access a file. The session layer keeps all files that are being downloaded and determines where it will go. This layer helps in session management, authentication, and authorization. When two devices need to speak with each other, a session is to be created at the session layer. Functions at this layer involve setup, coordination, how long should a system wait for a response, and termination between applications at each end of the session. It manages sessions between the application process, and it establishes, maintains, and ends communication with receiving device. Next is the transportation layer. This layer controls the reliability of communication through segmentation, flow control, error control, connection, and connectionless transmission. The data received by the session layer is divided into small data units called segments. Each segment contains a source and destination port number and a sequence number. A port number helps direct each segment to the correct application. A sequence number helps reassemble segments in the correct order to form a correct message at the receiver. Flow control means that the transport layer looks to see if the data is coming from more than one application and integrates each application into a single stream for physical network. This is the amount of data being transmitted in megabits. Error control is used when some data fails to arrive at its destination. The transport layer uses automatic repeat request schemes to retransmit the lost or corrupted data. The transport layer helps in the organization and coordination of data transfer between the devices. Its protocols include Transmission Control Protocol, TCP, which is built on top of the Internet Protocol, IP, commonly known as TCP/IP. TCP and UDP port numbers work at Layer 4, Transport Layer, while IP addresses work at Layer 3, Network Layer. UDP is faster since it requires no feedback if the data is lost. This is used when streaming movies, songs, games, voice over IP, TFTP, DNS, etc. TCP is slower since it returns lost data as TCP, www, World Wide Web, email, FTP, etc. Layer 3, the network layer, receives data segments from the transport layer. It works for the transmission of segments from one computer to another located in different networks. Data units in the network layer are called packets. This layer is used for logical addressing, routing, and path determination. IP addresses done in the network layer is called logical addressing. Every computer in the network has a unique IP address. The network layer assigns the sender and receiver's IP address to each segment to form an IP packet. IP addresses are assigned to each data packet to ensure that each packet can reach its correct destination. Routing is the method of moving data packets from source to destination based on logical address format as IPv4 or IPv6. It will use the IP address to locate the correct network, then the correct computer to transmit the data. Path determination is when a computer is connected to a server. There are many different ways to get to the computer. The fastest route from the source to the destination is called the fast determination. Protocols for the network layer are Open Shortest Path First, OSPF, Border Gateway Protocol, BGP, Intermediate System to Intermediate System, ISIS. These protocols are used to determine the best possible path for data delivery. In its most basic sense, this layer is responsible for packet forwarding, including routing through different routers. Routers at this layer help find the most efficient path. The way that the data will be sent to the recipient device is determined in this layer. The next layer is the data link layer. This layer receives data packets from the network layer. These data packets are senders and receivers' IP addresses. Two sublayers exist here as well: the Media Access Control (MAC) layer and the Logical Link Control (LLC) layer. In the network world, most switches operate at this layer. Logical addressing, the network layer, where the senders and receivers' IP addresses are assigned to each segment to form data packets. Physical addressing, the data link layer, MAC addresses of sender and receiver are assigned to each packet to form a frame. Media access control, MAC addresses are 12-digit alphanumeric numbers embedded in network interface card, NIC, of a computer manufacturer. The data unit in the data link layer is called a frame. The data link layer is embedded software in the network interface card. It provides means to transfer data from one computer to another via a local media, like copper wire, optic fiber, and air. The two basic functions of this layer is that it allows other layers of the OSI model to access the media using techniques such as framing, and it controls how data is placed and received from the media using techniques such as media access control and error detection. It provides node-to-node data transfer and handles error correction from the physical layer. In this layer, the appropriate physical protocol is assigned to the data. Also, the type of network and packet sequencing is defined. Finally, Layer 1, the physical layer. At this point, the data has been segmented by the transport layer, placed into packets by network layer, and framed by the data link layer. The data is now sequenced in binary zeros and ones. This layer will convert these ones and zeros into sequences to transfer over local media. It can be an electrical signal in case of a copper wire/LAN cable, a light signal in case of an optic fiber, and radio signal in case of air. This layer represents the electrical and physical representation of the system. This can include anything from the cable type, radio frequency link, as well as the layout pins, voltages, and other physical requirements. When a networking problem occurs, many networking professionals go right to the physical layer to check that all cables are properly connected and that the power plug has not been pulled from routers, switch, or computers. This is the level of actual hardware. It defines the characteristics of the network such as connections, voltage levels, and timing. All the data at this step will then go through the receiver's layers, the OSI model layers again in reverse order to decode the data, until it reaches the application layer, which makes the data visible to the receiver's computer screen. Now let's continue to section 3.1.4. A VPN or virtual private network is a technology that provides a secure, reliable, private connection between computer networks over an existing public network, typically the internet. It uses the internet to allow people to log into a network remotely and access its resources, but encrypts the connection to stop hackers. This makes VPN a popular way to support remote workers. A LAN that is connected to the internet. One computer outside the LAN is also connected to the internet. A VPN client and a server running on the lone machine and the original LAN. An internet connection, and finally, encryption protocol IPsec or SSL. There are two fundamental VPN technologies. 1. Encryption. Encryption is the process of encoding data so that only a computer with the right decoder will be able to read and use it. In a VPN, the computers at each end of the tunnel encrypt the data entering the tunnel and decrypt it at the other end. 2. Tunneling. Tunneling involves establishing and maintaining a local network connection that may contain intermediate hops. In this connection, packets constructed in a specific VPN protocol format are encapsulated within some other basis or carrier protocol, then transmitted between VPN client and server, and finally de-encapsulated on the receiving side. Lastly, Section 3.1.5. VPNs are very useful since it allows connections to a LAN that is protected from outside access through the internet. It also changed working patterns or telecommunications. For example, workers can connect to a company's internal network from almost anywhere in the world. It is a way for companies to allow their employees to access company resources outside the office, even from the comfort of their homes or when traveling. Now employees can work anywhere they wish, still having the company's resources. VPNs are very good at protecting people's private information when they are using public Wi-Fi services, such as at a hotel or at a coffee shop, because the VPN client software encrypts the data before sending it out over the internet. I hope you learned something from this video. Thank you very much for listening.